Hi everyone, how are you my dear children? Hope you are doing well in your life, healthy, safe and fine. So in last lecture we have discussed about the principle of flotation and how density plays a great role in deciding the whether object is floating or sinking. Today we are going to discuss the last topic of the chapter, that is relative density. Before going to relative density, let me again take you to the density portion. What is density? Density is nothing but it is mass per volume, children. Mass per volume. What does it mean? That means in a particular volume, in a certain amount of volume, how much mass is concentrated. That gives you density. What is mass? Mass means nothing but matter. So, more matters are concentrated in a particular volume. That means more compact is this. That means that is more dense. Hope I am clear with this. Okay? And what is the unit of density? This is kg per meter cube. Clear? And how you denote? We are big, smart, grown up children, so we will use rho. That is called rho. I have already used in previous lectures. Okay? Or simply you can use D also, small d also. In some books there will be capital D, so it varies. Okay? So from the definition, what we have understood? The density of solid is greater than the liquid or smaller than the liquid? It has to be greater than liquid. And this is greater than your density of gas. Why? You know solid is more compact, more number of atoms are there in a particular area, or you can say particular volume. Liquid molecules are far apart, spaced apart, so less denser, and gas obviously more spaced apart, all the molecules and atoms, whatever element you are taking. Okay, so that's why density of solid, density of liquid and density of gas in this order. Clear? Or still you are not getting what is density? Can you picturize what is density, children? Let me think. Day-to-day life, how to picturize? I think everybody heard of the name dense forest. What is this dense forest? Let us discuss what is this dense forest. I think you know, I know you know, you people are smart. So what is dense forest? Dense forest, suppose, now we'll go little off from the physics to understand the physics. Okay? So now, this is the area. Forest means trees will be there. So, suppose this is a forest and this much trees are there. Now tell me, same area, see, observe, same area I have taken. Same forest size. Which one is more denser? Which forest you will term as denser forest? Definitely this one. This is your dense forest. Why? Because in a particular area, see, in a given area, more trees are there. So it is more dense. Clear? Hope I am clear with the dense term, density. I think people can relate now the density term. Okay. From this, a good question comes to my mind right now. I think you people have seen when water is there and you put ice on it. You place or keep ice cubes in a water. What will happen? Ice floats in water. Why then? Why ice floats in water? Ice is a solid. How come? We have just now discussed density of solid is greater than your density of liquid, and in the last lecture we have seen if it is greater than, if this density is greater, it has to sink. Then how come ice floats in water? Children, please remember, when you are freezing water, actually there will be, water means H2O, there will be hydrogen bonding. I am not going into the detail. But in layman term, I just can tell you, when it freezes, when water becomes ice, molecules are spaced apart. That means in ice cube, there are lots of spaces, gaps are there. So in a particular volume, lots of spaces. Okay. So if, forget about volume right now, you have freezed water and you got your ice. Okay. I am telling these spaces are more. Okay. Between the molecules, more spaces are there, gaps are there. So if more gaps are there, then what will happen? Volume will increase or decrease? Let me know. Definitely volume will increase. You know, I think everybody knows about volume. Don't tell me and I need to explain what is volume also. If you want, I can explain that also. Please give a comment. Then I can relate what is this volume. Okay. So when molecules are spaced apart, that means you are increasing your volume. And you know density is equal to mass per volume. So particular mass, particular amount of water you have taken to freeze, to convert into ice. So your density is now inversely proportional to volume. Hope I am making any sense right now. Density is equal to mass per volume. So density is proportional to mass and inversely proportional to volume. Clear, children? Now volume increases. In case of ice, what will happen? Density decreases, children. So ice density is less than your density of water. Density of ice is less than density of water. That's why your ice floats in water. Why ice floats in water? Important question. Hope I am clear with this. Now we'll discuss about today's topic, that is your relative density. Relative. What does it mean? Relative density, children, as name suggests, it is something relative, nothing absolute. That means when relative means you are comparing something, that is a relative term. Okay. So density, relative density means you are comparing your density. Suppose I'll be telling my height is more. I am having more height. More height. Is it specific? Is it absolute? Who will decide my height is more or not? Then I have to compare with somebody. There has to be some reference point to compare my height. Okay. Suppose Geeta, take one girl's name, Geeta. Geeta is 6 feet tall. Okay. I am 5 feet 2 inch. That means I am smaller. My height is less than Geeta. So I am referring. This is your reference point. Suppose you are having 6 feet 2 inches height. That means you are taller than this. So this is relative. Are you getting, children, why this relative term? So here we are relating two densities. And in your syllabus we are taking water as your reference. Okay. That means we are relating two density. One is density of a substance, that you are having anything, wood, gold, silver, whatever it is, and you have to compare that with water. Clear, children? And that water also, and the condition has to be certain. That means you are taking water, then the temperature condition, pressure condition, everything has to be taken care of when we are going for a reference substance. Clear, children? So density of water at 4 degrees Celsius. Density of water is how much? Is every book it is there. 1000 kg per meter cube. Meter cube because volume. Kg for mass. Clear? Mass for volume density. So this we are going to take water as our reference substance. Clear? Then what is relative density, or you can say it is specific gravity also. Another name is there. Specific gravity, children. What is this? Relative density or specific gravity. This is nothing but, can I write as RD? This is nothing but density of substance and density of water. Clear? This water is this. We are talking about this reference. Okay. So you can write this as mass of the substance divided by volume of the substance. Clear? Then what is this? Mass of water and volume of water, or cross multiply. RD is equal to, you can write mass of substance, okay, divided by volume of substance into volume of water divided by mass of water. This also you can write. And as you can see, density is nothing but the ratio of two, relative density is nothing but ratio of two densities. Then what is the unit of relative density? No unit, because you are dividing the same density. So unit, there is no unit. So relative density has no unit. Then exactly what is this relative density is helping us to understand what? Why we are taking so much of pain to read this relative density. How it is going to help us. That means what is the physical significance of relative density. Let us try to understand what is the physical significance of, what is the concept, you can say. What is the concept? What is the fundamental behind this term relative density? Okay, let me try. Suppose this is your container and we are taking water, and now I'll place a wood in the water. Okay, so relative density means this relative density, actually this relative density or specific gravity gives the fraction of object submerged in water. Are you getting? When a object floats in water, this part, this is submerged in water, this part only, this fraction gives you the relative density. So it gives you the idea how much, what is the volume, what is the fraction is immersed in water. Is it clear, children? That means this is one thing. It will help you to understand what is the fraction of object submerged in the liquid or water. Since we are taking reference as water, so I am telling frequently the water term. Okay. And with that also, with this relative density concept, we can find out the density of substance also. Any substance. And it gives very accurate value, children. Okay. Let us try to understand what is that. Suppose this is your wood and relative density of wood is suppose 0.8. It is given. What does it mean? 0.8. That means 0.8 into 100. What is this value? 80%. That means 80% of wood is submerged in water. Am I clear, children? When this wood is floating, while this wood is floating, 80% of wood, 80% of this block is submerged in water. Okay. So this is, that means the particular, this part of volume, 80% of the volume is submerged in water. Clear? Another way to look at it again. Let us see. Relative density means, already we have discussed what is relative density formula. Density of the substance divided by density of water. So we'll write density of wood divided by density of water gives you 0.8. Okay. From this, what we can find out? Density of wood is equal to how much? 0.8 density of water. You know density of water, it is fixed 1000. So you can easily find out what is the density of the substance. Okay children? Hope I am clear? Okay. Another data to remember. What is the data? Let me tell you. When relative density is greater than 1, then what will happen? The object or the substance will sink. You can say the object will sink, not substance. Obviously that object is made up of substance. Okay. And you will be thinking, why then you have altered substance? I enjoy doing this little bit of bekofi. I know you people can catch me. Please catch when I am uttering such nonsense. Okay. So object, and that object is made up of that substance. Hope I am clear with this. And when relative density is less than 1, it is going to float. Okay. See the children. Now that means 0.8 fractional. So here this is less than 1, 0.8. Clear children? Now it is floating. Hope I am making sense now. So your object is floating because from this what we are getting? Object density is less than your density of water. Water density. Whatever we have studied from last 2-3 lectures, again I am proving this with relative density also. So lots of reason, lots of things, lots of, we can say, variety of things to look at a particular subject in. You can say, you can broaden your knowledge, you can broaden your attitude towards the particular topic. Just don't go word by word from book, go word by word, but try to understand what is there inside, why it is telling so, why that line is there. Try to understand that. See, again we came back the condition what we have studied already. So from relative density, slowly. So this you will mug it up. In book it is there. Then you will mug it up. But why it is there? Try to understand why it is there. Okay? Then you will not take the pain to mug up. You will understand. And when there will be application based questions, so-called hot question, you can answer it. Hope I am clear with this? Okay. And hope this lecture is not boring. Relative density, you people will be thinking so easy, why to teach? Okay. Now let us discuss iron. The density of iron is 7.8 children. Okay. So that means when you place a iron nail, we have already seen this experiment in water. What is happening? Iron nail will sink. Let us see. We'll now visualize, or you can feel that. Now 7.8 into 100. So what is this value? 780%. Yes, 780. See, what is this? What is this, children? Your relative density is now greater than 1. And you see 780%. That means this is your water, 780%. 100% is inside already. 100%. So that means your iron nail is going to sink. Is it interesting? I don't know. I find it very interesting. Hope you are getting what I am trying to convince you. Clear, children? Okay. Another important question, last. This is the last part of our lecture. Let me tell you. We have seen the density of ice is less than your density of water. if people have seen in geography water, there will be iceberg. Okay, huge iceberg will be there. Clear, children? And ice is having relative density of what? Let me first write. What is the density of ice? Density of ice is 920 kg per meter cube. Okay, let me find out what is the relative density. Density of ice divided by density of water. Okay, children. So 920 divided by 1000 and no unit, kg per meter cube, kg per meter cube, get cancelled. Okay, so relative density is equal to 0.92. 0.92 means what is the fraction of ice inside the water, submerged in water? So 0.92 into 100, 92%, children. Just little bit of tail will be above the surface of water and everything 92% is submerged in water. From this, another important question they used to ask in exam, tell me why icebergs are dangerous to passing ships. Why iceberg is dangerous to passing ships? I think you can now visualize. Since major part of your iceberg is inside the water, so it is difficult for a ship to estimate the exact size of the iceberg because only this much is visible. Other part is completely inside the water. So it is very difficult for the ship or the captain of the ship to estimate the size of an iceberg. So there is danger of the ship colliding with the iceberg. Hope you are getting this theory. Is it clear, children? So what is the function of relative velocity? Why we are studying relative velocity? Relative velocity is helping us to see relative velocity. You know the relative density of water. If you know the relative density, just cross multiply, you are getting your density of any object. So accurately we can find out the density of any object. And second thing, relative density gives us this idea. What is the fraction of the object submerged in water when the object is floating? Okay, children? Okay. Last, just tell me what is the instrument to measure the relative density of liquid. Previous lecture. Hydrometer, children. Hydrometer is used to measure the relative density of liquid. Hope I am clear with this. Hope I am clear with this. Okay, children. Done. So finally gravitation chapter is done. So in next lecture I will discuss some numericals. Then we will start with our next chapter, that is most interesting but very important motion chapter. Okay, I am having that anxiety. I know lot of things to say, lot of things to convince you people. Hope how this lecture is making sense to you. I am trying my best to convince you. Hope I will continue the same journey with you. Maybe I can help you in understanding physics, not in boring way, but in little bit of, we should have little bit of fun while studying physics. I am having fun. Hope you are also having fun while watching this video. Take care, children. Do well, concentrate, focus, study. Okay? Thank you very much for watching.